Okay guys, this is the first of, I think I've come up with 10 problems. This is the first problem from chapter 5.2. And I'm just going to read to you what's on the screen. This 5.2 is the in-class example number 4. We're going to prove using mathematical induction the summation of 1 plus 5 plus 9 plus ... plus 4n minus 3 is equal to n times the quantity 2n minus 1. So I'd like you to pause the video now and work this out on a piece of paper. And when you're done, unpause the video. Okay, I'm going to start doing it now. As usual, we will start with an aside. And I'm going to rewrite this summation using summation notation. So this is k equals 1 to n of 4n minus 3 is equal to n times 2n minus 1. Okay? Actually, that's really the only thing that we have for the aside, so now I'm going to do my base case. And we're going to set n equal to the lowest possible value, which is 1. There are some problems in the book where n can be lower or higher than 1. So just be careful for if there were any other, if this said, like, for instance, for values n greater than or equal to 2, then you would have to set, that would be your base case, n equals 2. In this case, it's n equals 1. So we're just taking 4 times 1 minus 3, and we're asking if that's equal to 1 times 2 times 1 minus 1. 4 times 1 is 4, minus 3 is 1. Sorry, 2 times 1 is 2, minus 1 is 1. 1 times 1 is 1. So we've proven our base case. Now we're going to do the induction hypothesis. And all I'm going to do is I'm going to set n equal to, what can I use? I guess I'll use L. Okay. So I'm just going to rewrite this sum, but instead of using n, I'm going to use L. So that's the summation of k equals 1 to L of 4L. I'm sorry, I messed up here as well. I keep doing that. That's not supposed to be n, that's supposed to be k. So this is 4k minus 3 is equal to L times 2L minus 1. Now comes our induction step. So what this summation is, or what we're trying to do now is to L plus 1. Okay? This summation here is from 1 to L. So I'm just going to rewrite this summation. And then I'm going to add one more of this 4k minus 3, but instead of, or let's say 4l minus 3, but I'm going to do 4l plus 1 minus 3. For every time I see L here, I'm going to replace it with L plus 1. And this is L plus 1 times 2. L plus 1 minus 1. So this summation here, summation k equals 1 to L of 4k minus 3, well, we have that is up here as well. That's the same formula. So I can just replace that summation with this right-hand side of the equation, which I'm going to do now. I'm going to distribute. This is 4L plus 4 minus 3. So that's 4L plus 1. And I'm going to distribute here. This is 2L plus 1, or I'm sorry, 2L plus 2 minus 1. So this is L plus 1 and 2L plus 1. At this point, the right side is as simplified as I'm going to get it, so I'm going to now leave it alone. All right. I'm going to distribute this L to this parentheses here, so that's 2L squared minus L plus 4L plus 1 is equal to dot, dot, dot. This is 2L squared plus 3L plus 1 is equal to dot, dot, dot. Now I need to factor this. So 2L, L, let's see. So I think it's going to be plus 1 and plus 1. So 2L squared, 2L plus L, that's 3L plus 1. Yep. And we notice, in fact, let me take out that dot, dot, dot. Oops. We notice that these two things are the same thing. So QED, we're done.